Integration is the opposite of differentiation. That is why it is also known as antiderivative. To evaluate these integrals, we do the opposite of differentiation. These are definite integrals because they have limits. For the first one, we're evaluating between 0 and 2, where 0 is the lower limit and 2 is the upper limit. The second integral, we are evaluating between 1 and 3. 1 is the lower limit and 3 is the upper limit. Let us integrate. To integrate, we drop this 2, then we look at this x. X has a power, this power is 1. So in integration, we increase powers by 1. So we say x, so the power here is 1, but we are going to increase it by 1. So we write 1 plus 1. So whatever new power we've put here, we divide it over like that. So we say 1 plus 1. Then plus. We have 3x. Increasing this power by 1, we write 2 plus 1 over 2 plus 1. As for the limits 0 to 2, we can just put them here, the lower limit and the upper limit. Let us simplify. We have 2x, 1 plus 1 is 2 over 2 plus 3x, 2 plus 1, 3 over 2 plus 1, 3. Our limits 0 to 2. We can simplify this expression. 2 into 2, it's 1. So we have 1x squared plus 3 into 3, we have 1x to the power 3. And this is the limits 0 to 2. At this level, we begin with the upper limit 2. We substitute it on x. So replacing this 2 on x, we open parenthesis, then 1, open this 2, we put the 2 on x, then power, plus 1, open parenthesis, 2 here. So we have 2, we do this, to the power 3. We close like that. Then we introduce a minus like that. Then on the other side, we substitute the lower limit. So wherever there's x, we substitute 0. So we have 1, 0 to the power 2 plus 1, 0 to the power 3. We close. Let us simplify. We have 1, 2 to the power 2, we get 4. 2 to the power 2 is 2 times 2 plus 1. 2 to the power 3 means 2 times 2 times 2, which will give us 8, like that. Then we close. Minus here, 1. 0 to the power 2 is 0, because 0 times 0 is 0. Plus 1, and 0 to the power 3 means 0 times 0 times 0, which will give us 0. We close. We continue simplifying. 1 times 4, we get 4, plus 1 times 8, we have 8. We close. Minus 1 times 0 is 0, plus 1 times 0, we get 0. We add the two numbers. 8 plus 4, we get 12. Minus 0 plus 0, we have 0. And 12 minus 0 is 12. So this is the solution to this definite integral. The second one, we have the integral, and we're evaluating between 1 and 3 of 4 dx with respect to x. So whenever you're given a constant number, a number which doesn't have a variable, we are supposed to introduce that variable. So this 4 has an x, but that x is raised to the power 0. So we are supposed to show it so that we see exactly what we're doing. So we have 1 to the power here, 1, 2, 3. Then this 4 can also be written as 4x to the power 0 dx, like that. So the x is there, but it is to the power 0. Why does it make sense? X to the power 0 is 1. Any number raised to the power 0 is 1, apart from 0 to the power 0. So this x to the power 0 is 1, and 1 times 4 will give us back 4. So this expression is just the same as this one. Now let us integrate this expression. We bring 4x, increase this power by 1. So we write 0 plus 1. We divide by our new power, which is 0 plus 1. Our limits, we have 1 to 3, 1 to 3. Now, let us simplify this and do the substitution. So we have 4x, 0 plus 1 is 1, over 0 plus 1, we have 1. Our limits, 1 to 3. X to the power 1 is just the same as x without a 1. So this expression is just the same as this. And 4 into 1 is just 4. So we have 1 to 3, like that. We can now do our substitution, starting with the upper limit. So the upper limit is 3. So we open like that, open parenthesis. So we have 4 here. So let's put the 4, then open like that. Now substituting the 3, so we have 3 like that. Then we close. Minus. On the other side, we can now do the replacement for the lower limit. So we have 4. Our lower limit is 1. So we put 1 like that, and we close parentheses. And we can simply multiply 4 times 3. We get 12 minus 4 times 1 is 4. Then we can apply subtraction. 12 minus 4, we get 8.